Can everybody hear me okay? I suppose so I can hear myself. So just before I start doing this presentation, I'd like to talk to you for just about a minute about meshIQ. I'm going to assume that many of you are not familiar with the company meshIQ. Perhaps you've never even heard of the company, actually. So I'd just like to talk to you about meshIQ, which is a software company. And we tend to work with organizations of a certain size. Most of our customers are large customers, large organizations. About 60% of the companies that we work with are in banking and finance. In fact, 7 of the world's 10 largest banks are customers of meshIQ. And we also work with organizations in other industries such as retail, insurance, and manufacturing, and in healthcare. Now, some of the organizations that we work with, some of our customers can rightly claim that their key operations are actually driven by RabbitMQ. But for the most part, most of our customers would probably say that RabbitMQ is in fact just one part, even though it's an important part, of a rather large jigsaw puzzle of various messaging and streaming technologies. And what we do with our platform is we provide a platform that provides observability as well as management and message flow tracking for a large number of messaging and event streaming platforms, some of which you see presented here on this slide. Now, this platform, it's designed to be used by stakeholders across the entire gamut, the entire spectrum of DevOps, everyone from full-time administrators to application developers, architects, and people who work in application support teams. So as you can well imagine, the needs and the requirements, the priorities of these people are actually quite different, very diversified. And our objective, our ambition really, is to provide solutions that exactly match the requirements for each of these stakeholders. So I'm going to be speaking to you today about one use case in particular. I'm actually going to show you 3 very short use cases that represent some of the more commonly encountered situations that we encounter when we work with our customers. And on the third one, that's where I'm going to spend particular focus, particular attention. But I'll start with this one. This slide, as you can see, is called Single Point of Control for Messaging and Event Streams. When we're working with people in shared services teams, so administrators, they're responsible for not only RabbitMQ, but also other messaging and streaming technologies, we frequently hear the same kinds of requests. So administrators, they tell us that they're responsible for the governance of diverse messaging and event streaming technologies, and they're tasked with creating and maintaining objects across those environments. They need to be able to propagate objects and their attributes across development and user acceptance testing and production environments. They often tell us that they need to be able to identify and retire from service unused objects safely for reasons of configuration management. And of course, they also have to take backups of their configurations rather regularly. So these administrators tell us that what they want to be able to do is to accomplish all of these tasks for all of their platforms, no matter where they're hosted, whether that be in an on-premise environment in their own data center or in multiple cloud environments, hybrid cloud environments. And they want to be able to do these things through an integrated tool set. So that means through a web UI, naturally, in a spontaneous fashion, but also they want to be able to do this through an integrated UI that's applicable, an integrated API, application programming interface, across these different technologies. Now, when we're speaking to people in applications development or in application support, we find that their needs, their requirements are actually very, very different. And these are people who are dependent upon messaging and streaming, which they consider quite rightly to be their application infrastructure. So they need to do things like test their messaging flows. They need to be able to do this rapidly and easily. They want to inject and visualize test messages in their development environments. And also, more importantly, application development teams tell us they want to be able to have a self-service capability so that they can manage and maintain their own objects, at least in development and QA environments. Well, both of the stakeholders, whether in shared services and responsible for administration or people who are responsible for crafting, developing applications, they really want the same things. They want a messaging or streaming environment that's highly reliable with high throughput, that's always on. So any type of self-service capability that we would grant to any stakeholder within an organization has to be very, very tightly secured. It has to be extremely granular to give people access to only the objects that they need to work with. And above all, it needs to be fully auditable. So that's one of our principal use cases. Another one, there we go. More and more of the organizations with which we work are adopting what they refer to as an infrastructure as code approach, which means that they want to be able to manage the tasks of creation and of maintenance of these objects across these multiple systems with less human involvement. So in order to do these things, they turn to technologies such as Puppet or Ansible Tower, which enables them to author playbooks, which contain descriptions of the desired state or the targeted state of the systems that they're working with. So with the organizations with which we work, what we hear is people are saying they find it challenging in cases where they're dealing with multiple messaging and streaming technologies to be able to manage in an infrastructure as code approach the complete stack of their application infrastructure. So this is where we come in and help them with a unique REST API that can be used for infrastructure as code, where multiple messaging and streaming technologies can be addressed through a common pattern, a common API, whether those systems be hosted on-site or on the cloud. So this is the last use case I'll present to you, the third actually example or vignette, and this is the one I want to focus on principally in this presentation. This slide is called Better Observability of Application Workflows Through Tracing and Tracking. So many of the organizations that we work with tell us that they find it difficult, they find it challenging to find out why some workflows sometimes exhibit inconsistent performance. And these organizations tell us that in the past they've turned towards different technologies, most notably application performance monitoring tools and also tools that do log analytics. But most of these organizations, in fact all of them, tell us that without having real visibility of what's happening within the messaging layer, they have a kind of a blind side that prevents them from seeing the bigger picture of what's happening in these application infrastructures. So our input to this is that in order to get better observability, real observability into application workflow performance, you really need application flow tracing and tracking, and you also need the ability to perform message profiling. And it's really equipped with these two functions that you're able to really see the interactions that happen between applications and your messaging infrastructure. So you'll notice on the screen that I'm showing you here, there's two graphics that are presented. On the left-hand side of the screen, I'm showing you a representation of an application workflow that is actually a trading workflow for a major investment bank. And you'll notice that here there's a certain number of stages that a financial transaction goes through when we're processing a trade, for example. You'll notice that there is a stage of taking an order, confirming that order. There's a process of validation and finalization that happens in this workflow. And despite the fact that we see that there's multiple applications that are involved, there's also multiple messaging and streaming technologies that are involved in exchanging these messages and to enable these applications to communicate with each other, right? So, the key point here, really, the essential point, is that without these messaging and streaming technologies, and in this instance you see there's Kafka, there's RabbitMQ and IBM MQ that are present. Without these messaging and streaming technologies, this financial transaction simply cannot be accomplished. So messaging is essential. And on the right-hand side of the screen, what you'll note is there's a graphic that represents the process of workflow tracing and tracking. And you'll notice that this process happens in essentially 3 phases. So there's a phase of data collection, potentially from multiple sources, that's followed by a phase of a phase where we have dashboards a phase of analytics and correlation and indexation of that collected data. And then finally, in the last phase, there's the visualization of the collected data in the form of dashboards that are readily understandable by multiple stakeholders. So actually, a 3-phase process that's being used here. So as you can well imagine, when we're collecting data from application workflows like these, potentially we're dealing with different sources. As I mentioned, Kafka, IBM MQ, RabbitMQ, very prevalent in financial institutions. So different techniques, different tactics are used in order to collect that data. But given here we're at the RabbitMQ Summit, I'm just going to concentrate for the purpose of this presentation on how we work with RabbitMQ for this purpose. So you'll notice that this is a multi-step process as well. So in order to collect data, we actually leverage and make use of the RabbitMQ Firehose Tracer, which is a built-in plugin for RabbitMQ. And what the Firehose Tracer does is it takes messaging events and streams those to a topic exchange, which you see here, amq.rabbitmq.trace. Now, those messaging events can be streamed to a queue or optionally to a file. In fact, a file that you can actually visualize directly within the RabbitMQ admin console. You can actually see this within that user interface. Now, once we've collected that data, we need some rules that determine how we're going to make use of that data. So we make use of a rules file that defines the data collection point and also defines the messaging events themselves and their correlators. In other words, defines the rules by which we'll associate these messaging events together, these produces and consumes. Now, this rules file also contains a set of parsers that enable us to make sense of the business data that's contained within messages, things like order numbers or invoice numbers or geographic regions or even sums of money. So in addition to the rules file, we make use of a properties file that allows us to define configuration options for message flow tracing. And among those configuration options, the most noteworthy is probably this one, the sync destination, that tells us where we're going to be streaming the collected data. And then finally, you'll notice at the very bottom of my screen, though, the word data collector appears. The data collector, in our instance, is a Java executable. It's a simple jar file that enables us to collect these messaging events from the data source or data sources and then take those messaging events and then stream them to the sync destination, which in our instance is our platform, which I'll talk about a little bit more. So, message flow tracing can be vitally important for organizations that have extremely important, extremely critical workflows, and it can help us to identify problems in application workflows, things like bottlenecks or latencies or slow processing. It can also help us to locate what we call missing messages or lost messages within our system. Now, sometimes messages have a rather large value. You can imagine in a banking application, for example, payments can be sums of money that can exceed easily hundreds of thousands of dollars. So it's very important to be able to identify these things rapidly. So these problems that often happen when an application workflow is inhibited or interrupted by some unseen chain of events is an area where we can help. Now, we can also help in the area of message profiling, which allows us to, in fact, extract details such as invoice numbers or product codes or geographical regional codes, and which also allows us to do summarizations and aggregations of that data, like, for example, the value of a series of orders that transpire between 2 time and date stamps, right? Message profiling can be very useful for identifying application workflows that are dysfunctional. There we go. So as I mentioned, our customers who in the past have attempted to make use of technologies such as APM or application performance monitoring or log analysis are those that are most interested in this type of technologies because those systems have delivered disappointing results in the past. So to get better observability of flow performance, you need to be able to see the execution timings of an application workflow from beginning to end, or we call end-to-end views of execution of workflow performance, but also, just as importantly, the execution timings of the actual messaging events themselves. That is to say, the sends and receives of messages across these diverse systems. And in some cases, some of the customers with which we work, they have rather stringent requirements in terms of service level objectives. They have, for example, workflows that are expected to execute within seconds or sometimes even milliseconds. So it's really essential to be able to identify the service, the workflows that correspond to their service level objectives and those which do not meet their requirements. So, as I mentioned, conventional tools for application performance monitoring simply don't deliver this level of visibility into what's actually happening within the messaging layer of your application workflows. So if you consider this screen for a second, you'll notice that it's divided into three parts. And at the top portion of the screen, we see summarized data about a series of application workflows that have been executed between 2 time and date stamps or over the last hour or last 3 days or something of that nature. You'll notice at the top left-hand corner of the screen, it shows what is noted here as being an activities count. I think I can press that, maybe not. So the activities count represents the number of application workflows that correspond to given search criteria that were executed during that elapsed time, right? And in this case, you'll notice there's 891 of these that were executed there. You also see information about the total number of flows that either met or failed their service level objectives and other summarizations that are presented here also. Around the middle of the screen, what we see is for a selected workflow, so one of those 891 workflows, we're zeroing in, focusing in on one selected workflow. And there we see the messaging events, that is to say the sends and receives of those messages. And each line presents information about that messaging event. We see the timestamp of those events. We see the messaging resource, so the queue, RabbitMQ, that was concerned by that messaging operation, and also the details of the content of that message that are captured at the moment of execution. And then all the way at the bottom of the screen, you'll notice that we're showing here is a topology, a graphical representation of that workflow that shows us, for example, the messaging event, the messaging resources, and also the execution timings of those messaging events, those sends and receives that happen in that case. Now, there's a certain number of expectations that people have, our customers notably have, with regard to application workflow tracking and tracing. People expect to be able to define objectives for workflow execution, so both end-to-end execution of timings for workflows. They also have expectations with regard to the content of messages themselves. So if you imagine, for example, an order workflow where there's typically, an order is taken, which is followed by then, let's say, a shipment and then an invoice and then a payment, for example. If in that case, when orders are being taken, if a message were to contain something like a field, let's say, that says 99 item out of stock, well, that could be something that you could be very interested in with regard to a service level objective. We want to flag, for example, any workflow that it does not compare well with our expectations in terms of either execution or actual message content. So in addition to these service level objectives that one can set, you also expect a message tracking solution to leverage machine learning. So the system should be capable, and ours, in fact, has this capability of learning the difference between business normal and business abnormal behavior. So we're able to recognize, for example, outliers or anomalous conditions that happen within application workflow execution. And probably most importantly, when these anomalies arise, when we discover transactions, business workflows that don't meet those service level objectives, what we always attempt to do, is send an alert to a third-party system that's responsible for capturing alerts. So a typical example is opening a ServiceNow ticket when an application doesn't meet its requirements. So on this graphic here, I'm showing you some of the details about the solution architecture for the meshIQ solution for message flow, track, and trace. And as I mentioned earlier, there's actually essentially 3 phases or 3 steps within this process of message tracking. There's, of course, the collection of data from one or more messaging and streaming sources. There's, after this, a process of analytics and indexation of the collected data. And then finally, rendering or restoring the data to the user in a way that the user can more readily consume and understand. So you'll notice that within our solution architecture, the first entry point here is what we refer to as our data gateway node. And it's at this point that we take stream data from multiple sources and inject it into our system. Now, during the second phase, which involves analytics, indexation, correlation of data, you'll notice that there are 2 services here that work conjointly to provide these services. There's our data compute node, based on our proprietary microservices infrastructure, combined with a certain number of messaging services, open source messaging services that are part and parcel of our solution architecture. And also, this phase is highly reliant upon the data index node cluster, which is in fact a cluster of data storage nodes that are responsible for storing what are potentially, in some cases, very, very large volumes of data. Now, this is actually very elastic. In some cases, organizations are streaming literally terabytes of data, every day upon day, and that data needs to be stored in a persistent fashion. It needs to be indexed, and it needs to be rendered to the user very, very quickly. So, whether it be a few 100,000 lines of data, or literally much, much more, literally millions, we want to be able to render that data to the user to meet their expectations, literally within seconds, independently of the volume of activity. So that concludes my presentation for the highlights of the solution for message flow tracking. Just want to illustrate here in conclusion some of the example use cases, and I'd say the key value adds of a solution of this type. Message flow tracking, it can provide us with a solution that addresses a certain number of challenges. It can be very useful for identifying bottlenecks and latencies in application workflow execution. It can help us define missing or lost messages. It can help us find data according to multiple criteria. So based on what you can find out information about the messages that you're searching for. And I think most importantly, based on those same criteria, those search criteria, you can group application workflows together according to these criteria for the purposes of validation and for summarizations and analysis. And it also enables us to manage the service level objectives and the expectations of different organizations, and most importantly, monitor and alert upon workflows that don't meet those expectations when we encounter problems of different sorts. And that's about all I wanted to tell you today. All right. Thank you very, very much for your attention. And if you want to know more about this solution, I'm actually doing demos of the product at our exhibition booth, meshIQ, today in this center. You can also visit our website, www.meshiq.com, to find out more information. And that's about it. I thank you very much for listening to me.
Okay, any questions? I can throw you a question real quick about some of the machine learning you mentioned around observability. What are some of the insights you've seen introducing that into your platform?
I think probably like the most common one that we encounter are end-to-end workflow execution. Naturally with every iteration, the system gets smarter, so to speak. It starts to realize what what is the expected behavior for the execution timings of a workflow from end to end, and when it sees either parts or the entirety of a message workflow that exceeds, let's say, the normal behavior, where we typically see a message workflow that executes in, let's say, 2 seconds, and all of a sudden we see one that lasts like 5 minutes or more. Obviously, that's an indication that there's some, unforeseen event that's impacting impacting the workflow. That could be due to a variety of factors. It's typically, I could say the most typical use cases are in fact application code that has changed between version N-1 and the current version. There can be other external factors such as, for example, networking or database processing or almost anything. So, while we can't, claim that we can accurately point to exactly, the exact problem, we can indicate the portions of a workflow. These are usually multi-hop workflows. We can indicate the portions of that workflow that show us like an unusual or anomalous behavior, and that allows the analyst, when he's looking at our our topology views and the analytics that we provide with the interface, that allows them to zero in and see what portions of the of the workflow are causing problems. So between 2 hops, for example, between this producing, I should say message producing application and a subsequent or downstream message consuming application, we can zero in on that and say, here, for example, at this edge, we see 2 minutes of execution, whereas typically it's it's 10 times less than that. So it's it's an indication of a problem within a workflow. Thanks for that question.
Thank you.
How long does it take for an organization that's not using a tool like this today to, once they decided, okay, I'm going to use it, how long does it take to implement that for them?
That's a great question. So, it can be very variable. I would say typically, to be frank, when a single messaging technology is used, naturally that's simpler to implement, right? When there's multiple technologies involved, and that's very, very frequently the case for large organizations where you have things like, for example, IBM MQ and RabbitMQ and ActiveMQ that are involved, that involves, it really requires, application knowledge. And this is where application architects come in typically. People that are able to define things like correlators that we can put into our, XML-based, rules-based. And very, very frequently what we get is people will say, well, is there any way that we can make use of, let's say, information that resides within the message header of some of these messages? And you'll notice that as soon as you have, that can be a valid use case, for example, when you remain within the realm of a single messaging technology. But as soon as you traverse technology boundaries, so to speak, at that point you become, it's essential to become reliant about business data that's actually contained within the messages themselves, and that's really where the application architect comes in. So I would say, this is the type of thing that can be done, literally within days or weeks to put it in place. Our software itself is installable within minutes, but to be frank, you raise a good point. It really requires knowledge of the application workflow from the viewpoint of, let's say, the application architect to be able to implement, a solution like this with Brio. So the more knowledgeable, the application architect is, the faster deployment path. I think it's something that could easily be achieved within the space of, let's say, a week or 2, if you've got the right people and you've got the right data.
Hi, my question is, how do you pass the application workflow ID all the way from the client to meshIQ? Like, is one application workflow using like a single RabbitMQ cluster, or do you pass it as like a property in the message somehow? So
the information, if we leverage the Firehose tracer, which I showed in this example, right? It's actually quite nice to use because there we leverage a built-in facility. We've got an existing API that's already streaming that data to what is more commonly it's a RabbitMQ queue that's mapped to a topic exchange, right? So that information gets streamed to that topic exchange, and through the use of our data collector, we point our data collector to that point. So using a properties file, or a rules file, I should say, we identify the name of the RabbitMQ in which those streaming events, those messaging events are going to be put. Now, if that goes over different different areas, let's say. There could be potentially, why not, more than one broker involved, more than one cluster involved, or actually multiple messaging technologies. What that means is we're actually pulling in data from multiple sources, which could be, for example, for some of our customers, a Kafka topic, for example, from an IBM MQ queue manager, from a RabbitMQ queue as well. And then information, once it's pulled into our system, which is a central point of collect, that's where the analytics and the correlation come into play, and that's where we start to make sense of the data and identify those hops, correlate them together, and render it to the user as one integrated workflow. Yeah. Thank you, V.
Any other questions? Thank you so much.
Thank you. Thank you very much. Yeah.